Okay, so initial state transition is 0.25 and 0.75. Okay, respectively. Then for the first question, we're supposed to find the initial state distribution. Okay, so what you do is for initial state distribution, you just multiply the initial state, which will be 0.25. Okay, I'm taking you through the process. You will solve it at your end. 0.25 times the first transition probability. Okay, so that will be times what? Times this matrix here. Okay, so times 0.8. Okay, or better still, write the figures down, so that I go to a fresh page and then we solve it together there. So take note, 0.80. Okay, so I'm going to a new page. So we have, I hope you can see my screen, the whiteboard. Hello, class.
No, sir.
Say, showing now.
Okay. Good. Yeah. So we had R, or since we've written that, let me just go straight to the solution. So for initial state matrix, that's going to be 0.25 and then 0.75 times our matrix, which will be our matrix, which is what? 0.8, 0.2, and then we have 0. Is it 7? 0.3. Am I right? Hello, class.
Hello, sir. Sir, please, 0.3, 0.7.
Okay, thank you. So 0.3, 0.7. Okay, so then you multiply to get your initial state distribution. Okay, you multiply like we said earlier in previous classes. So you multiply like I'm showing you, okay? Then you get the initial transition distribution. Then the next one, you were asked to find the probability that somebody will use the rapid system in the next 2 months, okay? So, which means that you first have to find P2, okay? And then once you find P2, you find what? That probability that the state, the process at T equals to what? 2 is going to be a rapid, okay, transition mode, given that we started, okay, from whatever process. Here they were not very specific, but they just said what is the probability that you will be in a rapid what mode, okay? So we'll be looking at the transition probability for being at T2 in a rapid mode. It could be whether you are coming from a rapid mode or from an automatic what mode. Okay, good. So what do you do first? Like we said, find P2. So let's clear this side and find P2. That will give us, that should be 0. I'm doing the multiplication straight away. So we're going to have 0.8 times I wanted to do the multiplication straight away, but for all you know, by the time I finish, somebody will ask me to repeat everything. So let's do it systematically. So 0.8, 0.3, 0.2, 0.7. Okay, then let's do the multiplication. So we have, so we have 0.8. Okay. So we have 0.8 times 0.8 plus 0.2 times what? 0.3. Then we have 0.8 times 0.2 plus 0.2 times 0.7. Okay, very good. Then next you're going to have, for the next row, that will be 0.3 times 0.8 plus 0.7 times 0.3. Then we have 0.3 times 0.2 plus 0.7 times 0.7. Okay, so this will be 0.64. Okay, plus 0.06. Okay, so when we come here, that should be 0.7. Then this will be 0.24. Okay, plus 0.21. So 0.24 plus 0.21. So that should give us 0.45. Then the next one will be 0.16. This will be 0.16 plus 0.14. So when we add that will be 0.3. This will be 0.3. Okay, and of course, we know this will be 0.55. Okay. So if you want, now we had rapid and we have, let me change the color. So I have rapid, I have automatic. Okay, and then I have rapid, automatic in the second transition. Okay, So if I want the probability that a system, that somebody will still be using what? A rapid method. Okay, that will be it. Okay, so that is the distribution we have here. So from a rapid to a rapid method will be 0.7. And then from an automatic to a rapid method is going to be what? 0.45. Okay. Then for the final question, it says in the long run. So long run means steady state transition. So for steady state transition, you have to solve like we did earlier. So you solve pi 1, pi 2, okay, times the system, which is P of ij, okay. So the given initial transition matrix, okay, is equals to pi 1, pi 2, okay. That you need to do from your end. And then find the probability pi 1 and pi 2. Any questions so far? As we are wrapping up for Markov chain. So any question? Hello class, are you there?
Yes, sir.
Okay. So that is the final thing we are looking at under Markov chain. We've looked at the various states. We've looked at the one-step transition probability. We've looked at the Kolmogorov-Chapman's equation or theory, which led us to the M-state transition probability. We've looked at the time, the state holding time. We've also looked at what? The initial state transition probability or the initial transition distribution. We've also looked at the steady state transition distribution of the process. Okay, so with this understanding, we should be able to tackle some Markov project. So on that note, we wrap up for Markov chains. And then I'm going to play a little session into our next topic, which will be queuing methods, okay? Modeling queuing systems, which is going to be based on both a discrete and a continuous modeling tool, okay? So our module 2, when you check from your notes on Limas, the course is in 4 modules. Module 1 is the introduction of the course. Module 2 is on Markov modeling. Module 3 is on queuing systems and examples of queuing models. Module 4 is on model validation and verification. So we are done with Markov modeling. We are going to the next example, which will be on queuing models, okay, which once again will make use of the Poisson distribution. We also look at the exponential distribution and the geometric alongside, okay? Yeah, and saying so, let me just throw our minds back. You can see that in the Poisson process, we've actually looked at other distributions like the geometric distribution, which is for the state holding the state holding probability. We've also looked at this conditional probability theory, okay, alongside in the Markov modeling technique. So let's look at an introduction to the queuing system. Then we wrap up today's class. The next slide instead of watching the video. So in our next lecture, we'll be looking at a second modeling technique, which is queuing models. Okay, queuing models are basically mathematical models which are used to model queues. Okay, and we have so many queues which happen around us on daily basis. Okay, so we'll be seeing. In fact, we'll just have an overview of a queuing model and then see how to do that modeling. Okay, and if possible, also demonstrate it using MATLAB. So if possible,
have your computers with MATLAB installed, like I told you, okay? So that in the next class, we can do some little demonstration, a little practical online, okay? So we'll be looking at queuing models. There's a video I wanted to play, but I'm sure that will also give us a little bit of a challenge. It talks about the types of queues, if you can see it. Okay, no need for the volume, I'll explain that. So we can have the single lane phase. We can also have single line, multiple phase. We can have the multiple line, single phase, and then we can have multiple line, multiple phases. So this is a single line, single phase scenario where you have a single queue, okay, arrivals, okay, we have a single queue, and then we have a single service, okay, process. So example, it says self-service patient, or yeah. Then we have a single lane, multiple phase. So I mean, you walk to the physician's office, you have a first check-in at the nurse's area where you take your measurements, okay, temperature and all that before you move to the doctor. So it's a single line, multiple phase, okay, scenario. Then we can also have a single phase, multiple line, single phase system. So you have your queue, we have a single queue, but you have several cashiers, okay? Very good. So we come in and then we have cashier 1, we have cashier 2, and then you have your service resolved. Then we can also have multiple line, multiple phase service. So based on these scenarios, we'll be looking at how to model, okay, using MATLAB. I know you've already been introduced to the concept of queuing models. So go back to your notes, read on queuing models before the next class, and then we'll see how to demonstrate that. And then based on the model we'll generate, we'll run some simulation and then proceed with the next model, which is on validation and verification of simulated results. Okay, thank you very much. If you have any question, you want to ask, and then we bring the class to an end. Yeah, if there are any questions, yes.
Okay. So that is for an introduction to queuing models. Okay. So next week, try and have your computer set up with the MATLAB. Okay, you still set up your computer, even though we'll dedicate the time to looking at the mid-semester scripts. We'll also look at the question itself, and we'll look at the assignments you submitted so far and the challenges. Then once we are done, we can continue with the Markov model, the queuing, okay, modeling, and simulation. Any questions for me? Any questions, class, before we hang up? Can you hear me?
Yes, sir.
Yeah, any questions or any final remarks before we wrap up the class?
No, sir.
Okay. Okay, so on that,
No, sir.
on that note, we'll end today's class here. Okay, and I'll see you all next week.
Thank you.
Enjoy the rest of your weekend. Bye-bye.
My, sir.